This video is for homework 2 for CSC 578 neural networks and deep learning. The first question asks me to apply the hyperparameters for cost functions, quadratic cost, cross entropy, and log likelihood. So I will go to the cost functions first. This is my code. Cost function for quadratic cost was already implemented. For cross entropy, I had to implement the derivative of cross entropy, and this is the function for derivative of cross entropy. For log likelihood, I had to implement both of the function and derivative. So the function is implemented by this and derivative is -1 by a. For the sigmoid one, we were already given with the sigmoid class. These are the activation functions. So now I will talk about sigmoid, tanh, relu, and softmax activation functions. Sigmoid is already done. Tanh I had to implement. For tanh, this is the formula for tanh twice of sigmoid of 2x minus 1. This is what this formula is doing, and derivative of tanh is given by 1 minus tanh of x square, and this is what I have implemented. For relu, the function is returning me maximum from 0 to z, whatever it is, so it will give me the maximum value. The heaviside function for derivative, I need to return 0 or 1 for relu. So the heaviside function gives me 1 if the value within the array is positive, and gives me 0 if the value within the array is 0 or negative. For softmax function, this is the formula for softmax. I have just implemented the formula. Okay, the regularization L1 and L2. For regularization, I had to make changes in my code. For SGD, in SGD, I have implemented if loop. If regularization is none, I have not selected regularization, but in case I am giving the parameters, it should not affect my function, my cost function. So I have just made sure that lambda is 0 in that case. Update mini batch function gives me the contains the regularization changes. So self.regularization is, if it is L1, then this is the formula to incorporate L1 changes in weights, and then for L2 regularization, the weight changes will be given by this formula. If no regularization was selected, then these are the changes, or these are the weights, the default ones. For biases, no regularization is needed. And other than this, total cost contains regularization changes. So this is, if regularization is L1, then this is the formula where to calculate cost. For L2, this is the formula to calculate cost, and for no regularization, this is the formula. Dropout rate. To implement dropout rate, I made changes in feed forward. Feed forward now have the keep gives me the percent of, not the percent, the number of links to keep in my network. So 1 minus dropout percent gives me keep, and then using this formula, I am randomly selecting the links within my network, and activations are updated according to those links and then are returned. In the backprop formula, I am I'm seeing if the activation function, I'm calling the activations based on the activation functions of hidden layer or output layer. I have done the experiments provided by the professor, and these give me the similar kind of results that are mentioned in the IPython notebook. And apart from that, the homework, the part 2 of the homework that asks me to do some experimentations. So I have done the experiments. These are good, but except for ReLU and log likelihood. The ReLU using the hidden layers ReLU and the cost function log likelihood, I am getting nan values. The nan values are because ReLU is giving me 0 for negative or 0 values, but log likelihood, it takes log of 0, so it gives me nan or infinity. These are the code changes that I did for this assignment. Thank you.